import the label encoder class from scalar. So these are the steps. Just first you implement it, complete the importation part. Okay. So now 11:20. So let us finish this step by 11:23. Okay. Sorry, it's now 1:20. So let us finish this step by 1:23. And then I will put this part in the Q&A also, so that you can do that smoothly. So those who are able to complete this during the hands-on part, fine. Those who are unable to complete this, they can do it from the by looking into the chat section of the Q&A part. Okay, so please finish this step and then we shall move ahead. In the next step, we will see that how to load the dataset from the external sources. I will show you that how to access the URL from, like I mentioned, that uci.edu you can access the German dataset. So that particular put we can put in the URL section and then we can access the other part. Okay. So I shall wait for another more minute and then move to the next part. So please finish this part. It's now 1:22. Okay, so let me post a chunk of the code in the comment box section. So I am sending in few split. Okay. So from import pandas as PD, then from scalar.model underscore selection import train test split. These two part I am sending all together. Okay. Then I am sending from scalar.model .linear underscore model import logistic regression. From scalar.metric import accuracy underscore score. Okay, so this part I am sending here. This is the second part. Okay, so from scalar.linear underscore model import logistic regression, and the next part from scalar.metric import accuracy underscore score. So this is the second part I have kept there, and then finally importing the label encoder class from scalar. So last part will be from scalar.preprocessing import label encoder. The last part I am putting there. Okay. Okay, so the entire part has been shared with you. I'm going back back to the original notebook so you can cross check the alignment. Okay, so this is the particular part which we discussed so far. Then just have a look at it and cross check. So I will wait for a few more seconds towards the next portion, loading of the data set. Okay, so now let us discuss the next part. So I hope now the other portions are clear to you. So here you can see URL equals we are putting the URL of the ics.uci edu. So from their archive, you are getting the data set of the. Since there are 20 features which we have discussed few minutes back. Okay, so these 20 features will have the 0 to 19 index value because Python is a zero indexing language, all of you know. So you can check the list which I discussed index value wise. If you go there, so there are 20 features. The 21st feature was the outcome, which we okay. So that part will be removed. So in overall, if we see, we are keeping. That's why we are keeping the column as f feature I for I in range 20. Okay, it will from index value 0 to 19. Okay, and then plus outcome, which is the 21st column. Okay, so this is how the column has been prepared, and then what we do, we will read the CSV file. So data equals to read dot pd dot read underscore CSV. The first argument is your URL is given there. The second argument, data limit white space names equals to. Okay, so delimiter you can check this particular part. So what we are doing, this delim underscore white space is true. It can specify the delimiter between columns is white space, space or tabs instead of the comma. So it will be either of comma. Okay, this is the first part. Then in the next step, we can what we can do, we can encode the features. Okay, so before we move to the next step, please complete up to loading dataset and arranging the overall dataset stuff. Okay, so just this particular portion. So it's now 120. So finish this step by 131. Okay, then we shall move to the next portion. Sharing in a comment because type meaning. Okay. So I have shared the dataset link. Please type the remaining part. Okay, so this part I have posted there. Now just type the remaining part, columns and define the data. Okay, so it's now 130. Please finish these two lines by 132. Then we shall move to the next part. So I repeat, in this step, we have done the loading dataset procedures. First of all, we have shown the URL, exact URL where we are accessing the data. Then column, we are assigning the columns along with the features and the outcome. That is the target variable. And then what we have done, we have pd.read underscore CSV, we have read there basically we have made that delim underscore white space operation space underscore or the tab space. Okay, so those spaces have been kept. Okay, now in the next step, what we will do, we will basically move towards the encoding of the categorical features. So there we'll see the label encoders. Okay, it will convert the categorical text data to the numerical labels. Okay, because there are you have seen that there are categorical text data present. If you can remember. Okay, if I go back there, you see there are categorical variables along with the numerical categorical variables are present, and for your understanding purpose I also present it here. Checking account status, credit history, these are the categorical data, so you have to convert them in the numerical. We have been able to finish this particular segment. Okay, now we shall move towards the next part, that will be the encoding of the categorical features. So to avoid the word limitations, I am sending one by one. So URL I already shared under the loading of the data set. So I am sending the remaining part. Those who already completed successfully or typed successfully, fine. Others, please concentrate here. So check your Q&A section. So I posted this part. Okay. So the assigning column, defining column is done. Then reading of the CSV file. Okay, I'm sending this portion of the code as well. So I also posted the remaining part. Okay, now I'm going back to the original notebook so that you can easily follow. Just have a look. I'm waiting for a few more seconds. Just have a look so that you can align it properly. And the loading dataset part. So first will be URL, then column, then data. And this way it will be. Okay, now let us move to the next part. I hope that all of us are on the same page. You have done it successfully. So it's now 1:35. So let's move to the next part. That is encoding of the categorical variable. So lay will equals to labels encoder. So it will basically encode categorical text data into numerical for in data column. So what we are doing, it is retrieving the names of all the columns in the data frame. Okay, now basically what we'll do, we'll now next we'll check with we will put if statement. So if data called dot d type equals to object, so we'll check that if the data type of the column is object, okay, which is typically means that the column contains all the categorical text data. Okay, and then in the next step, what we'll do, data call equals to transform applied over data call. Okay, so it will basically fits with the encoder to the column data and transform the text labels into the numerical one. Okay, as simple as that. So please finish this portion. Okay, now it's 136. So finish this portion by 139. Okay, so I'm highlighting the portion. I encourage you to type it. So up to this. Then we shall move towards the prepared data part. Okay, so before that, please finish this highlighted portion, encoding of the categorical features. Hello. Yes. I'm in one organization.
Sir, your voice is not coming. Voice is breaking. Sir, no, your voice is not coming.
Okay, so that all you are doing it, I shall wait for a few more seconds and then I shall move to the next part. So see, there's the course are accustomed with it, they know it very well. Those new to it for them, I'm telling. You see, after the there is some given starting the if statement. So with if statement, again in the next line giving some space. So why you can't put unnecessary space? So it's applicable by Am I audible? Hello?
Yes, sir. Now audible, sir. But before something is
Audible to you?
not audible. Yes, yes. Now audible, sir.
Okay, fine. So as I was mentioning, okay, so there might be some problem related to the headphone. So I am opening it out, removing it out. So as I mentioned that Python or Pythonic platform, okay, So you can't put some unnecessary spaces, but wherever the space is required, you have to give it. Otherwise, it will be the indentation error. Okay, so that's why I am telling you to just to observe the areas where we are starting the for loop or if else statement. Okay, so you can see some spaces are given there. So these spaces are not unnecessary spaces; these are required spaces. Whenever you will type the code, you make sure that you are giving that spaces. Otherwise, it will lack with error. Okay, so these tricks, unlike the other lines which you have implemented here, you see some spaces there. After for loop, when the if statement is starting, we have given some space. After the if statement, whenever we next line, okay, data call equals to lay.fit underscore transform data call. So whenever we are fitting the encoder to the column data and transforming the text level into the numerical data. So here we also have given some spaces. So if you don't give that, it will land up with the indentation error. So to avoid that type of the error, make sure that you are putting the proper spaces. So that is why this particular I am telling you all to type by yourself so that you can learn this portion. And encoding categorical features is one of those sections. There will learn the tricks of writing the code. There are tricks. So Python or Python like Keras, TensorFlow, PyTorch, everybody will see that. Okay, very very important while writing codes. Okay, so let me put this particular portion in your Q&A section also, so that all of you can do it carefully. So I am sending in two parts, okay, just to avoid the word-related limitations. I hope the entire part should go. The first portion, entire part has been posted up to for loop. Okay, under the for loop, there are the remaining portion. Okay, that will be the if statement followed by the data call, where we are basically fitting the lay dot fit transform over the data call. Okay, so only the first line has been delivered. The next line I have to put it here. The last line I'm sending you. So if data call dot dtype equals to object, the first line has been given. Data call equals to lay dot fit transform. Data call. Last line I am posting separately. Due to the word limitation, it has not been posted there. So I'm sending the last line also. Just cross check. Okay, I am just resharing the screen. Just cross check. Okay, cross check this one, and then we shall move to the prepare data section. Okay, so I'm waiting for a few more seconds, then we shall move towards the discussion on the preparing dataset part. Okay. Okay, so let us move to the next part. That is the preparing data. Okay, so in the preparing data, you see the predicted variables capital X, data.iloc, colon, comma, colon -1. So here you see under the index, left-hand side of the comma, that means the first argument section, or the first parameter section you see, it is basically selecting all the rows. Then colon -1, it is basically removing the last column. Okay, the last column has the outcome, data labeling is available there. So to avoid any type of the bias, while prediction, we are removing that. Then Y, which is the basically your response variable or the target one. So here we are keeping the outcome. So data outcome one dot as type int. So it basically creates the binary target variable y. Okay. So where the values of the outcome will be converted to 1 if they are equal to 1, or otherwise it will be 0. So the comment also added there. Okay. So target variable, we are basically converting them into the Boolean values, true, false, with corresponding integers 1, 0. Okay. It was in the Boolean value to 1, 0. That is the movement we are doing there with the help of that dot as type int. Okay. And then in the next part, like you are accustomed with this part, similar type of the part we have implemented during the first term, that a train test split xy train test size 0.3, random state 42. So random state, we are putting some integer value 42 because whenever you are reproducing the result, you can get the same value. Okay, and the test size 0.3, that means the 30% will be for the go for the entire data set will be for the test data set, and remaining 70% for the training data set. So that type of the train test split is available, option available under the scikit-learn model. Okay, storing under the xtest, xtrain, ytrain, ytest, all along with the explanations are available here. You can check there. So those who are new to it, for them I have added the explanation. So training set feature xtrain, as the name suggests, test set features for the xtest, ytrain for the training set of the target variable, ytest for the testing set of the target variable. Okay. So these all explanations are available. Why we are using, how much we are using for the 10 test split, etc. Explanations are given there. So if you are having fear that whenever we will after the session you may forget it, but it will not happen like that, because along with the code I have added all the comments, so that whenever you go back to the code for practicing, you can easily extract all the details from those comments. Okay. Now, before moving to the training of the logistic regression part, okay, please prepare the data set. Please complete the writing of the prepare data set part. Okay, then we shall train a logistic regression model. Okay, and followed by that we shall implement Lime to generate the explanation. Okay, so it's now 148. So please complete this part by 151. Okay, then we shall discuss the next portion. So I shall wait for another more minute and then move towards the next portion. So make sure that all of you are typing it. Okay, so now let me share this portion to your Q&A section so that you can also reproduce this part. So I am sharing 3 lines separately, okay, one by one sequentially. So I have posted this portion also. Okay, so please finish this part, align them properly. Those who are unable to do it, please finish this part, align them properly. Okay, just look at the screen. I am going back to the screen sharing mode. So this is my screen. Just cross check with it. Okay, so I shall wait for a few more seconds and then move to the next part. That will be training a logistic regression model and checking the accuracy. Okay. So just have a quick look and let us be in the same page. So those who already typed successfully, fine. Those who are still doing it, please just cross check with the code I posted and let us be in the same page. Okay, so now let us move to the next portion. I hope that picture is clear to you. Now, training a logistic regression model. Okay, so here logistic regression first argument what we will put it max iter equals to 1000. Okay, because you see it will be the maximum iterations that the solver will take to use the converse towards the proper solution. Okay, and then you see random state equals to 42. Same logic that whenever we shall use that, it will give you the same output. Okay, so that's why random state we have to keep some integer value there. Okay, and then lr dot model and lr underscore model dot fit x train and y train. So it will fit the logistic regression using the train data set. Okay, so it will have the features for the training set of the model, and y train will having the label target variable corresponding to the training data set. Okay, so entire explanation is also added there for you. You can cross check there. Okay, and then what you will do, you will implement the check accuracy part. So lr dot model, okay, lr underscore model dot predict, you are applying over x test. Okay, and you are getting the predicted outcome and storing under the y print, and then you are printing the accuracy. Okay, print accuracy score underscore score x y test y print. So you will get 0.76. That means 76% of the time the model will basically you are getting the correct outcome. Okay, 76% of time, which is reasonably satisfactory factor. Okay, or reasonably high, you can say. More than 70% is not bad. Okay, so 76% you are getting as an outcome. Okay, so this particular segment you just complete, and then we shall move to the next part. Okay, so it's now I think two Okay, it's now 156. So please complete this step by 159. Okay, so here I repeat, we have done training of the logistic regression model, then creation of an instance, okay, with the specific parameter where we have defined the max iteration 1000, okay, so that you can converge towards this solution faster with the help of the 1000 iterations, and then random state 42, okay, to generate the same outcome with that particular fixing the random state at integer value. And then what we have done, we have fit it over the X train and Y train, okay, and then checking the accuracy by applying LR underscore model dot predict over X test, okay, and finally printing the accuracy, okay. So please implement this part, and once you are done, just let me know. So I shall wait for a couple of minutes more and then move to the next part. So it's now 1:58, so try to finish it by 2 p.m. So I shall wait for a few more seconds and then move to the next part. Please, those who have not done it yet, please complete it. Okay, so let me post this portion in your Q&A window one by one. So I am posting line by line. Okay, so there are 4 lines of the code. I will post one by one to avoid the word limitations factor in the Q&A section. Okay, so first line I have posted there, where you will get the details of the max iterations and random state. Then I am putting the LR model dot fit to fit over X train. Okay, where you will have the features of the training data set and their levels Y train. Okay. just check it has been posted successfully, and then checking the accuracy. So LR underscore model dot predict. Okay, so we are predicting the outcome over the X test and storing it under YPRED, and then I will send you the printing of the accuracy part. Okay, YPRED equals to LR underscore model dot predict X test, and then printing of the accuracy. Okay, so done. Now I'm going back to the original notebook. Just check those who have done it successfully, fine. Those who are still doing, just cross check. Okay, the one by one alignment so that we can remain in the same page. Okay, so training of the logistic regression model, then creating an instance, okay, of logistic regression model with the specific parameters like max iter equals to 1000, random state equals to 42, and then checking the accuracy. Okay, so these three parts we just check. I shall wait for a few more seconds and then move to the next part. Okay, so let us move to the next part. So in this particular segment, what we shall do, so I have to rerun the part actually. Okay, let me finish the explanation and then I will generate the plot again. Just a second. Let me just rerun the execution. Due to the maybe some internet issue or something like that, the output which has appeared that is not coming properly. So I'm rerunning the each portion. Okay, just a second. Okay, fine. Just a second. Let me just go back. So now we are checking the Lime outcome. Okay, the explanation. Already we got the prediction. Now we are checking the explanation generation. Okay, so okay. So in the first step, what we'll do, we'll import the Lime tabular explainer class from the lime dot lime underscore tabular. Okay, it will help you to generate the explanation. Okay, and then what we'll do, we'll create the Lime explainer. So under the Lime explainer, what we'll do, we'll basically initialize the Lime tabular explainer object, which can explain the predictions of the machine learning model on the structured data. Okay, so then followed by that, what we'll do, we'll convert the X-train data frame into a numerical array of its values. Okay, and the next step, what we'll do, we will convert the Y-train data frame into a new NumPy array of its values, which are is nothing but the target variables for your training purpose. Then similar thing, what we'll do, we will assign the column names of the X data frame to the feature names parameter. So that's why feature underscore names equals to X columns. And then followed by that, what we'll do, we will specify the mode of the line tabular explainer as the classification. So that's why mode equals to classification. Okay. So I repeat the steps that what we have implemented here, the importation of the lime tabular explainer from lime.lime underscore tabular. Then we have created the lime explainer. Okay. So please finish up to these steps and then we shall move ahead. There we will basically explain a prediction. So it's now 2:07 p.m. So please finish these steps by 2:10 p.m. Okay. And let me know once you are done with it. So once you finish this, we shall discuss about the explaining a prediction and displaying explanation. Okay. So just finish this part. I shall wait for another more minute and then I will put this part in your Q&A section so that all of you can reproduce it successfully. Those who are unable to do it for them actually. Otherwise, if you have typed carefully, then fine. Okay, so let me just put this part in your comment box also. Okay, so I will do it one by one. Line wise, I will put there because of the limitations, word limitations. So first part, simply the importing part I am putting there, lime tabular explainer. Okay, so first line has been given there. Then explainer equals to lime tabular explainer, where the function is beginning. First line. Okay, I'm putting that one by one line sequentially. Okay. Then the next extend values. Then training underscore labels equals to y underscore train dot values. Okay. So this is the next part. Once we finish this, then feature underscore names equals to x dot columns. It will come into the next line. Followed by that, in the last line, it will be mode equals to classification. So keep them under single quote, okay? And then close it with the closing parenthesis. Don't forget to close the bracket, okay? So otherwise it will end up with the error. So just put the closing parenthesis at the end, which is in the next line. So the okay, we are done with it now. So I am just again going back to the screen sharing mode. Just check it. Already it is in the screen sharing mode, right? So no problem. Already I am in the screen sharing mode, so no problem. So it is there. So I am putting it from my GitHub. So I will share the link with all of you. Nothing to worry about it at the end. So all of you can do it. Okay, so this is my GitHub link. Those who are checking, for them I'm showing. Okay, so all those things are available there. So this is my GitHub username. So Sabyasachi123276. Okay. Anyway, so please finish this up and just cross check as you have gone there. Just cross check and then explaining of the predictions I will do, and then display of the explanations we shall discuss. So I shall wait for a few more seconds. Just cross check this board. Okay, so let us discuss about the explaining of the prediction. So sample equals to x underscore test dot ilog0 values. So what will happen? So ilog0 here basically this is likely a data frame containing the test set of your data. Okay, so this is, if you check, for example, ilog0. So this is the access of the, giving you the access of the first row. Okay, this is giving you the access of the first row, and then explanation equals to explainer dot explain underscore instance. First argument section, it will be the sample, and the second one will be the lr dot underscore model dot predict underscore probe. Okay, so it will do you the generate the model predictions, explanation for the model prediction, and followed by that explanation dot show in underscore notebook. So it will basically display the explanation. So if you see the product prediction probabilities, so 46%, basically 0.46. Okay, it is a prediction probability, and here if you see 1, it is giving you the 0.54. Very touch and go. So prediction probability purpose, if you see in the left bar chart, it is displaying the prediction probability for the two classes. Okay, so this blue part will give you the probability of the 0.46. Model predicts a 46% chance of bringing the class 0. Now this means the loan rejected. The loan will not be approved. And this orange part, which is basically giving you the class 1, the probability value is 0.54. The model predicts 54% of the chance it is belonging to the class 1 loan approved. Okay, so the left bar chart, this is the overall scenario. Okay, so blue and the orange figure, class 0 and 1, and the left bar chart. Okay, it is showing you like this. Okay, and then the feature contribution, if you see, so this will give you the feature contribution. So up to feature 0 to feature 19, there are 20 features are available. So feature wise different conditions are given there. Okay, so which one fall under the 0 category? If you see this will come under the 0 category, and this particular segment will give you the category 1. Okay, feature 7, feature 17, feature 15, feature 11, and feature 0, feature 2, feature 5, 12, 9. These are under certain condition for giving you the 0 class, and this class 1, while the loan is approved, it is coming under the with this satisfying certain condition related to feature 7, 17, 15, 11. Okay, so this condition has been explained here. So the middle chart, okay, so feature influencing class 0, features that decrease the probability of class 1 loan approved are shown in on the left. This is the blue. Okay. And feature influencing class 1, okay, features that the increase the probability of the class 1 where the loan approval is happening are shown in the orange color. So the length of the bar indicates the strength of the features impacting on the prediction. Okay. So those things we have seen, and the key features here, if you see the loan approved case and the loan rejected case, so few of the conditions has been quoted here. Okay, like for example, feature 17 is less than equal to 1 along with the contribution score 0.1. Okay, so loan approved. Or for example, feature 7 less than equals to 2 with the contribution score 0.11. Okay, loan approved. Or for example, the feature 15 less than equals to 1. Okay, with the contribution score 0.07, loan approved. Or for example, feature underscore 11 less than equals to 0. Okay, with the contribution score 0.07, loan approved. Okay, so this is how you can contribute. Or loan rejected case, like for example 0 less than to 0.00, like I have mentioned, or feature 2 less than equals to 2. So others will contribute negatively to the approval probability. So the loan will be rejected. So here if you see in the pictorial wise the contributions, that feature 0 less than equals to 0.00 with the contribution score 0.18, loan rejected. Feature 2 less than equals to 2 with the contribution score 0.13, loan rejected. Feature 5 less than equals to 0 with the contribution score 0.08, loan rejected. Feature 12 less than equals to 27 with the contribution score 0.07, loan rejected. Feature 9, okay, less than equals to 0.0 with the contribution score 0.07, loan rejected. Feature underscore 6 less than equals to 2 with the contribution score 0.06, loan rejected. So this is how it is happening. The prediction probabilities and the feature contribution, the loan approval or the rejection is given there. Okay. And these are the features and their corresponding values which you can look at there. So like I mentioned, this particular loan approval case, here we are depending on the 20 features. Okay. And the index wise, Python is a zero indexing language. So 0 to 19 is basically contributing towards the decision making. So this is how the lime actually help you to get the idea of the features. So table on the right, you can see the feature values, the list, the actual values of the features for the specific instance being explained. And these values can match the features in the middle chart showing their contribution to the predictions. So in a nutshell, what we can conclude that with the help of the line, actually we are being able not only explain it properly, but giving the clear idea to all the practitioners that whether certain loan can likely be approved or rejected. Okay, so this is how you can implement this particular segment. So I believe the picture is quite clear to all of you now. Okay, so this particular segment of the case study 1, line for the loan approval. So last part, those you can just complete, those who are doing it. Okay, so this portion, explaining a prediction to the displaying the explanation. Okay, just complete this step. I have already explained the output to you, so it will be easier for you to understand. So it's now 220. So finish this part by 223 before we can move to the next part. Okay, so I shall wait for another more minute and move to the next part. Please finish this portion. Okay, now let us explain a prediction. So I am putting this portion of the code in your comment box. So one by one, just put it and do it. So line by line, I am putting the one by one thing. So explaining a prediction, sample, then explanation, then displaying the explanation. Okay. So now let me just cross check with it. The steps which I am showing to you, just cross check. Okay, so I hope the things are clear to you, right? Okay, so now we shall move to the next part. Okay. So case study part is done. Now one remaining part of the today's session will be the another interesting topic of the explainable AI. So there we will discuss about the explainability in deep learning. Okay, using the attention mechanism and GradCam. Okay, so gradually we are going towards the higher order. So first we started with the some of the simple to intermediate level cases we have seen. So you have learned about the deal with the inbuilt data set. You can analyze them, you can predict them, and generate line and share. And the next part you already have implemented using the next cases. For example, if you are taking some real world data set for the loan approval prediction purpose, okay, you are applying the line over it and generate the explanations, okay, along with the prediction. And there we have used the logistic regression. And now we were going to get gradually moving toward this deep learning. Okay, so there you will see the deep learning using the attention mechanism and generate the explanation using the GradCam. Okay, so one of the explanation generation technique. Okay, so open up the new notebook. Okay, and let us implement this particular segment. Okay, so I believe, but just I'm assuming few things that you have the basic understanding of the deep learning and CNN. Okay, so I know that all of you are respected faculty members and in teaching domain, but everybody may not be have the same type of the experiences. So in those cases, I would request those who are in touch with deep learning, they will understand it fine. Those who are not touching with this particular topic, they can just go through some standard materials, online resources, or go through some standard book. So it will be easier for you to understand. Okay, and I believe that this particular segment will give you some idea that how to deal with deep learning using the attention mechanisms and generate the explanation using GradCam. Okay, so what I will do, I will just I added definitely some necessary theory part so that you can easily understand the concept. But still, to see this type of the things, the more you will practice and study, you will gain the more insight on this. So deep learning is nothing but the subset of the machine learning using the ANN or the artificial neural network to model and solve the complex task like the natural language processing and predictions or the image recognition. It can actually mimic the human decision making through the hierarchical feature learning. Okay, so this is the basic concept funda behind the deep learning. And the CNN, if we see the convolutional neural network, it's a type of the deep learning model designed for the pre-processing of the grid-like data. So image is nothing but the grid-like data. So it uses the convolutional layers to automatically extract the spatial features, pooling layers for the dimensional reduction purpose, and fully connected layers for the classification or the regression task. So CNN can excel in terms of the object detection related task or the image recognition task. Okay. Now, if we see the importance of the explainability in deep learning. So explainability in deep learning can refer to the ability for understanding and interpreting how a model can make its predictions. So it's quite crucial in terms of the building trust, ensuring the transparency, identifying the potential biases in the models. So in sensitive areas like the law or the finance or the healthcare, explainability helps stakeholders to make the informed decisions. It can ensure the model's behavior which can align with the ethical standard and the regulatory requirements. Okay, so this is why that we are giving so much importance of the explainability in deep learning. Now, another very interesting concept that is an attention mechanism, but it's a very simple one if we try to understand it. So, what does it mean by the attention mechanism in deep learning? So, it's a technique that can allow the models to focus on the specific part of the input data. Okay, and it can assign varying importance to different elements. Okay, so it can enhance the performance by prioritizing the relevant features, and also particularly in sequence-based tasks like the natural language processing, NLP, or the image captioning, or the speech recognition, which can enable better contextual understanding and make the improved predictions. So this is how the attention mechanism takes place. Okay, so it is basically a prioritizing some relevant features. So you are dealing with the features now. Attention mechanism will prioritize the relevant features. Okay, so CNN with the attention mechanism, if we talk about this, so it will combine the powerful feature extraction capabilities of CNN, okay, with the ability of the attention mechanisms, which can prioritize the important regions or the features in the input data. So while CNN can excel in at learning the spatial hierarchies in images, they treat all features equally within a receptive field. Okay, so the attention mechanism can address this by dynamically weighting the relevance of the different features of the region, and it can enable the model to focus on the most critical areas. Okay, so this is how the CNN works with the attention mechanism. So what are the key features which we are going to focus on here? So first of all, the feature extraction. So CNN layers extract the spatial features from the images or the other structured data, first of all. Second is the attention module. So in the attention module, for example, you can talk about the spatial or the channel-wise attention, which can highlight the most relevant or the important part of the features. Okay, this is a very simple. Attention means what? In generally in English term, what do we mean? That we are putting some spatial concentration in certain areas. So attention mechanism is same thing. So in deep learning, whenever you're using, you are basically focusing on some informative parts of the certain features. Okay, so that's why the name has been given like attention. Okay, and enhanced understanding, that integration improves the performance, and especially in complex tasks requiring the nuanced decision making like image recognition or the object detection or the medical image analysis. Okay, so this combination results in more robust, interpretable, and accurate models. Okay, so the GradCam concept, what is GradCam? So GradCam is basically, it's a gradient weighted class activation mapping. It's a very important concept for in terms of the visualization technique. So it can highlight the regions in an input image contributing most in the model prediction purpose, and it uses the gradients from the final convolutional layer to generate the heat maps. So as a result, what will happen? It can provide the interpretability by showing which areas influence the decisions, making the planning model more transparent and explainable. So this is how the GradCam works. Okay, so in GradCam, I repeat, it stands for the gradient weighted class activation mapping. Okay, it is basically a visualization technique that highlights the region in an input image, contributing most to a particular model predictions. Okay, and what will happen? It uses the gradients, okay, from the final convolution layer to generate the heat maps and providing the interpretability by showing which areas can influence the decisions. Okay, and making the deep learning models more transparent and explainable. And the steps associated with the GradCam, if you see, the first one is the forward pass. So the image is passed through the model and we compute the class code for a target class. Next one is the backward class. So in the backward class, what is happening? The gradient with respect to the class code is computed and backpropagated, and followed by the activation and the gradient handling. So we pull the gradients across all the channels of the last convolution layer, and these pulled gradients are used to weight the activations. And as a consequence of that, a heat map that can highlight the important areas of the images. So in generally, the normalization operation we implement. So in heat map is normalized between the range of the 0 to 1, and you can resize to match the input image dimensions. Okay. So what will be the importance of the GradCam heat map? So the GradCam heat map is applied to the image to visualize the important regions for the target class prediction, and the color overlay is basically used to enhance the visibility of the regions of interest. Okay, so the output will be a visualization of the image with the GradCam heat map, which can be superimposed on the top of it. Okay, so the region of the basically the image that can contribute most of the model's prediction will be highlighted in warmer color. So that means if you see the yellowish color or the red color effect, that means it is the most contributor in terms of the model prediction purpose. Okay, so this is how the GradCam heat map work. Okay, and the Cypher10 data set, which will be used for here, basically for the explanation purpose. So it's basically a collection of the 60,000 images, color images, 32 by 32 is the size, and you will have the 10 categories, and these 10 categories are airplane, automobile, bird, cat, deer, dog, horse, sheep, truck. Okay, these are the possible 10 categories. So it is basically used for training machine learning models in image classification task, where we are taking 50,000 training and 10,000 test images. Okay, now let us start the hands-on session part. So just before going to that, I'm giving a brief overview what we have discussed so far. We have briefly discussed the deep learning concept, then we moved towards the CNN, and after that we spoke about the importance of explainability in deep learning. Then we talked about the attention mechanism. and followed by that we also discussed about the CNN with attention mechanism, and then we discussed about the key features. So there we discussed about the feature extraction, attention module, enhanced understanding. Okay, then we talked about the GradCam and the steps associated with the GradCam, like forward pass, backward pass, activation and gradient handling, normalization, importance of the GradCam, heat map, and finally the Cipher10 dataset descriptions. Okay, now we shall talk about the hands-on part. So in the hands-on part, first portion, we will import all the necessary packages. So import torch, okay, then import torch.nn as nn. So like I mentioned that PyTorch, a framework for the deep learning, okay. Then we shall provide the tools for building the neural networks, for example, layers for the loss function. Then import torch.optim as optim. So it contains the optimization algorithms like SGD or the ADAM. Okay. Then import torch vision. So it can provide the utilization of the common vision, computer vision datasets. Okay, common vision datasets, models, image transformation. Then import torch vision.transforms as transform. So support the transformations for pre-processing in image data. Okay. Import matplotlib.pyplot as PLT. So it can enable the plotting and the visualization of results. Import numpy as NP. Okay, so for numerical operations on arrays, and then import CV2. So provides the image processing capabilities as OpenCV. So these are the necessary frameworks and the modules which you can import there. Okay, so just finish this step. So it's now 238. So complete these steps by 241. Okay, then we shall move to the next portion. Okay. Okay, so now let us move to the next part. So I am sharing this portion with all of you. Okay, just a second. In the comment box section, I have to put this one. Okay, so sequentially follow it up. I'm putting one by one. Okay. So just check in your comment box section, Q&A section. So I am putting one by one. All the necessary modules and all those things. Okay, so now the next portion which I dropped here, the import matplotlib.pyplot as PLT. Now import numpy as np, import cv2. Okay, up to this I'm also putting it here. Okay, so the entire portion has been dropped here. So now I'm going back. The next part. So here we have imported all the necessary modules and the framework. So just check out it once before we can move ahead for defining the CNN model with the attention. Okay. So here we will define a CNN with an attention mechanism. Okay, and then constructing to define layers and initialize the models. So I shall wait for a few more seconds and then discuss the next part. Okay, so let us move to the next part. Now defining CNN with the attention. So with CNN class CNN with attention nn.module. So here we'll define CNN with an attention mechanism. Okay. So now the super, whenever we are writing the super, under that we are putting the arguments like CNN with attention, comma self, and initializing it with int. So it basically refers to the parent class. Super is basically referring to the parent class of the current class, because current class is CNN with attention. So super is referring to the parent class of the current class. Okay. And then what we are doing, self.conv1, so equals, which we are assigning as the nn.conv2d. Okay, 364 3 padding 1. So 3 input channel. Okay, then 64 is the output channels. Okay, so if we check out there. Okay, and the padding value is given 1. Okay, in a similar way, if we check, for example, the self.conv2d, nn.conv2d, there's a second convolutional layer where 64 is the input channel, 120 is the output channel, padding equals to 1. Okay, so similar way you can define this particular layers, and then self.attention, where the attention layer equals to 128. Okay, so basically here we are getting the attention. We want to apply the attention on the second convolutional layer at the end of the day, because we are putting the entire attention on the second convolutional layer. So that's why we are applying it over the 128. Okay, where is the index value? Because 120 is nothing but the output channel, number of the output channel for the second convolutional layer. And then it can create a fully connected layer, okay, where we can map the one input of the size, mapping an input of size with the 128 by 8 by 8. Okay, and then what will happen, that 512 will be the units, output units from this particular fully connected layer. And then in the next case, self.fc2, this particular segment, what will happen? This is the final layer. You will take the mapping 512 units to 10 classes. Okay, that means hyper 10 categories. So 10 class, already we have mentioned that. And then finally the pooling layer. Okay, so there will be the 2D max pooling layer. So it will reduce the spatial dimension by half. and then finally self.relu equals to nn.relu. So relu activation function will be at the end. Okay, so make sure that you are doing it carefully. So please reproduce this particular segment. Then we shall move to the next particular portions. And those who are confused or finding deep learning new, for them I am telling that all the necessary explanations to the lines, corresponding lines are given. Okay, so nothing to worry about it. Okay, so you can see all those necessary explanations are added there. So those who are finding new to this particular field, they can easily grab those concepts. Okay. So finish up to this. It's now 12:47. So please try to complete this particular segment. Also, the next lines are quite easy. So I'm just completing this up. So for storing activities during the forward pass, so self dot activations equals to none. Okay, and then self dot gradients equals to none. So these lines will initialize the attributes self dot gradients and the self dot activations to none. Okay, so you can actually cover up to this. Okay, and the next section, register to hook to, basically we are doing the hooking operation, hook to capture the activations and the gradients. So self.com to dot register underscore forward underscore hook. Okay, you are applying it over the self.save underscore activation. So it is basically saving the feature maps from 2D during the forward pass, and then self.conto.register underscore backward underscore hook, self.save underscore gradient. So it saves the gradients during the backward pass. So we have spoken about the forward pass, okay, while saving the feature maps from second convolutional layer, and we also spoke about the saving the gradients during the backward pass. Okay, so these are the few areas which we have discussed. So CNN model with attention, then storing activation during the forward pass, then registering the hook to capture activations and gradients. Okay, so up to this we have done. These three segments we have covered. So please incorporate these portions and then we shall move to the next part. It's now 12:48, I think. Sorry, 2:48. So finish this part by 2:51. So then we shall move to the next portion where we'll talk about the functions like save activation, save gradient, all those things. Okay, so let me also put this part. Meanwhile, those who have completed, fine. Those who are unable to do it or still doing it, for them I am just sharing. Okay, so I will put the one by one lines here. So just make sure that you are doing it carefully. So follow the sequence the way I am putting it in the comment section. Okay, so just look at into the comment section of the Q&A. I'm putting one by one chunk of the code. Okay, so till first convolutional layer self.conv1 I have done. I'm now doing self.conv2 part. So self.attention I have given there. Up to fully connected layer I have shown self.fc1, self.fc2, then max pooling 2D, or 2D max pooling layer, self.pool. Okay, so how that downsampling is happening, you will see there. Then self.relu activation function, we are putting it for introducing the nonlinearity. And storing the activations using during the forward pass. So self.activations equals to none, self.gradient equals to none. Now then forward hook, self.com2.register underscore forward underscore hook, and then self.com2 underscore backward underscore hook. So these two things we have done, one for the activation, another one for the gradient. So one is the forward hook and another one is the backward hook. We are defining for the forward and the backward pass. So sequentially you put it there and just cross check with my original notebook. So I am just going back to my original notebook so that you can easily cross check. Okay, just have a look at it. Then I shall explain the save activation part. Okay, and save gradient part. Okay, so I believe all of you have checked it. Now what we shall do here, we shall see the save activation part. So self module input and output, this will be the arguments there. And then self.activations will be output. So this will assign the output of a layer of the module to the activation attributes, okay, which you can use later. Similar way, if save underscore gradient, okay, so there you will take the self as the first argument, module as the second argument, gradient input as the third argument, gradient output as the fourth argument, okay. and it will be used during the backpropagation, because this will define a method that can store the gradients during backpropagation. And self.gradient and equals to grad underscore output 0. So it will assign the first element of the gradient output to the gradient attribute. Okay, and then what we will do, we will define the forward pass method. Okay, so here what will happen, you will take the x which can process the input. Okay, and then followed by that, what will apply a series of the transformation for this input x. Okay, so there will be basically a convolution layer. Okay, which will be applied after first convolution layer. You will apply the ReLU there, and then you will implement the pooling operation. Okay, similar operation you will do for the second convolution. You will apply the ReLU function followed by the pooling operation. Okay, and then what you will do, you will do the attention mechanism after these two round of the operation. Okay, and then followed by that, what you will do, you will use the flattening operation. So this -1 under the x view will make sure that overall multiplicative balance should be there, because 128 into 8 into 8 overall figure which will come up after the flattening operation, that should help to reshape it properly accordingly. So -1 actually there, which will help, which is present in the first argument section. It helps that the reshaping should be done in a proper manner. Then again, what you will do, will apply basically this line. There is the fully connected layer. You will apply the ReLU function over it, and then finally again you will form another second fully connected layer, which we are assigning as the FCT2. So first fully connected FC1, which we applied over X, followed by the ReLU operation, ReLU activation function. Then second convolution layer, okay, you are doing it FC2, and then finally return X. So X is the statement that will return the output tensor from the neural network. Here basically we are doing the CNN operations. CNN. Okay, so this is how you can incorporate this particular segment. Okay, so defining the both the activation functions followed by the forward pass. You are defining the forward pass method. Okay, so this particular segment you do, it's now 259. So please complete these steps by 3-2. Okay, so as the time is going to over, so you just do it. A remaining portion, what I will do, I will explain, and I will share the GitHub link for this particular section so that you can easily extract the code. You don't have to type in that case, because already the time is going to over. So just do this part, and remaining part you can extract from the GitHub. Okay. And moreover, I will share my overall GitHub link so you can access the other content also, other repositories also. So just finish this part, then I will explain in overall. So I shall wait for another more minute and then move to the next part. Okay, now let us move to the next part. So defining the attention layer. So here what we are doing, defining a class named the attention layer, which can inherit the PyTorch NN module Then we have initialize method, define initialize method for the class, which can take the in channel as the input parameter. Then what we have done, we have applied the parent class attribute attention layer using the super function. Okay. Followed by that, what we have done, we have utilized the basically the shape. Okay. So here what we have done, we have applied nn dot parameter over torch dot random. So here what will happen? It means that one set of weights per input channel will be retained. And then what we are doing, we are defining the forward pass function over the model where we can specify the how the input X is processed through the network. And then torch.sigmoid, okay, you can apply the sigmoid activation function, okay, upon the attention weights. Okay, so it can produce the values between 0 and 1, and you can store it under the attention underscore map. Okay, and then apply the attention map to input. So return X into attention underscore map. So it will apply the attention map to input. Okay, and then gradcam function. So how to do the gradcam function there? So you will define the generate underscore gradcam. So it model will be the first argument, input image will be the second argument, target class will be the third argument. Okay, and then model dot eval. So it will set the model to the evaluation mode. So it will disable the behavior like dropout or the batch normalization. Okay, and then input underscore image unsqueeze 0, which can add the extra dimension of the input image, which can typically given for the batch processing in the neural networks. And then, okay, it can enable the gradient calculation. So input underscore image, okay, dot requires grad. So it can enable the overall gradient calculation. Okay, so this is how we are defining the gradcam function part. And then forward pass. So what will you do? You will basically apply the model function over input image, and you can process the input image through the model to generate the predictions. And then you will zero all the gradients. So model dot zero grad will zero all the gradients. Followed by that, you can back propagate to get the gradients with respect to the target class. Okay, so what it will do, so target equals to output 0 target class. So it can extract the value from the output tensor corresponding to the target class index, and target dot backward will compute the gradients of the backward tensor with respect to the model's parameter using the back propagation. Okay, and followed by that, what we will do, we'll get the gradient of the last convolutional layer. Okay, so what we are doing, gradient equals to model dot gradients. Okay, so it can assign the model stored gradient to the variables gradients. And activation equals to model dot gradient. So it can assign the model stored the activation values to the variable activations. Okay, and then what you will do, you will pull the gradients across all the channels. So torch dot mean. Okay, so gradient will be the first argument. Then you will keep 0, 2, 3. Okay, so it will compute the overall scenario. So basically 0 here, 2 will be the standing for the height and 3 for the width here. Okay, so followed by that height, I mean after defining the pull operation across all the channels, then what you will do, you will basically weight the activation by the gradient. So for I in range activation dot shape 1, so it will start a loop that iterates over the second dimension of the activation tensor. And then what you will do, you will basically multiply the pull gradient with the activation function here given like colon I colon colon. Okay, so it will multiply each channel of the pull gradient, okay, with the activation function. Then what you will do, you will take the average of the weighted activation. So heat map will generate basically the heat map with the help of this. So torch dot mean activation dimension 1 squeeze. Okay, so it will compute the mean of the activation tensor along dimension 1. Okay, and map it to the heat map. Now generated heat map will be normalized. Okay, so first doing that thing, the line will convert the heat map tensor to a numpy. That is very much important. Okay, so for doing that, np dot maximum, okay, we will do the heat map dot detach dot numpy. Okay, and then what you will do, you will apply the cv2 dot resize heat map. Okay, and then you will keep input underscore image dot shape 2 and input underscore image dot shape 3. So these are basically the spatial dimension of the height and width. Okay, so basically it will resize the heat map to match the spatial dimension. Okay, And then what you will do, you will normalize the entire heat map by dividing the each value in the heat map by dividing the maximum value of the heat map, and then return heat map. So the normalized heat map will return back. Okay, ensuring the consistent range of the values are already there for further processing of the visualization. And then visualizing function, what you will do, so you will put the definition of the display underscore gradcam. So input first argument will be the image, second argument will be the heat map. So it can define a function and display the gradcam that can take an image, okay, and heat map as an input to execute the entire operation. And then what you will do, image underscore numpy dot transpose 1 to 0. So it can rearrange the entire thing, rearrange the entire operation, and will initialize as the image. And then followed by that, what it will do, it will basically the scale the entire heat map to 8-bit integer value, okay, between 0 to 255, okay, and you are storing it under the heat map, and then you are normalizing it with the heat map values by converting them into the float 32 data, okay. So np dot float 32 applied over heat map divided by 255, okay. So it's nothing but the 2 to the power 8 minus 1 value, okay. So 2 to the power 256 minus 1 255, okay. So this is how you are doing it. And then overlaid image. So overlaid image equals to 0.4 into heat map plus 0.6 into image. So you are basically combining the original image and the heat map. So you are taking the 0.6 of the image, and then you are basically multiplying 0.4 into heat map. So what is happening there? Original image, it will be converted to the overlaid image with the effect of the heat map part. And then what you are doing, you are basically applying the plt.imshow function over overlaid image, and you are turning off the axes, okay, with the comment of the plt.axis off, and then plt.show. It will give you the plotted image using the matplotlib, ensuring a cleaner and the distraction-free visualization, okay. And then what we will do, we will basically execute the last part, okay. That line basically, if you see if name equals to name, so it can ensure the code block below, it can run only when the script is executed directly, because not imported as a module. So that's why what we are doing, if name equals to main. And then now let us load this cipher10 dataset. So here how we're doing it. So basically transform.compose transform to tensor to normalize 0.5, 0.5. So each channel, because it's an RGB image, so there will be each channel red, green, blue, and each of those channels have been converted, normalized. Basically, you can say normalization has been done. And then torch vision.dataset cipher10. So you will just define the root, then train equals to false, load true, transform equals to transform, okay. And followed by that test loader. So torch.utils, okay, data loader. So you will take the test set as the first argument, bash size 4 as the second argument, suppl equals to false. Okay, we're not doing any suppling there. Then initialize the model and load the first image from the test set. So what will happen there? Basically, attention, CNN with attention. Okay, you will store it under the model with attention, and then test set equals to 0. The first image you are doing the leveling. So first image you are taking as the sample image. Okay, so test set under bracket 0. So index, because first image will have the 0 index, Python is a 0 indexing language. Then target class equals to label. So you use the class label of the image, and then generate the gradcam heat map. So what we will do, generate the gradcam model with attention with the first argument, sample image will be the second argument, target class with third argument, and storing it under heat map. And then you are displaying the image with the gradcam overlay. Okay. So once you are displaying it, you are taking the sample image as the first argument and heat map as the second argument. So you will get this type of the effect, overlay effect. So here, interestingly, the area which are the red and yellow region, they are basically strongly contributing towards the prediction over the entire image. And the part which were the bluish effect, okay, they are contributing very weakly. Okay, so this is how you can make the decision making. So remember, the part which are the reddish region or the yellowish region, they are mainly making the effective contribution in the decision making, whereas the blue or the green areas, these are the making a very poor contribution, okay, because they have a very poor influence over the predictions, okay. This is indicating the lower activation values, okay. So red and yellowish part has the higher activation values, whereas the blue or the up to green part have the comparatively very lower active values in terms of the making the proper predictions, okay. So in a nutshell, we have seen the implementation of the CNN in through the predictions, as well as generating the explanation with the GradCam. Okay, so this is the GradCam heat map, and GradCam already I mentioned. It basically, this stands for the gradient weighted class activation mapping. Okay, what I'm doing, I am just sharing the notebook, this particular notebook link, GitHub link, to all of you in the comment box. So those who are because some portions are remaining from the execution, so that you can easily execute it. Okay, so I'm just putting it in the comment box section, so all of you can extract the code from this link and reproduce the result. Okay, so you will be able to do it easily. Okay, and
Sir?
the next part. Yes, please.
Sir, sir, your contact address, please. Basically,
Sure. I'm just
whole
sharing one by
session.
one. Everything I am sharing. I'm sharing everything.
Okay.
Yeah,
Okay. No.
So my mail ID.
Sir, everything is recording. My point is, whole session is recording. So, I mean, if your screen is shared, then everything we will get.
Okay, so just a second. I have already given my mail ID. You can mail me here, and let me share some of the resources. So already I have shared my GitHub link for this particular notebook. And
Sir,
along with that,
please sir, 1 minute. My point is that every whole session is recording. So if you show your email ID as a shared, means if you share your screen with your email ID, then we will get everything.
already I posted in the comment box. You can get it. Q&A section, I already posted it. We'll get it from there. I have posted my every resources I am posting in the comment box. Please check Q&A section. You will get all those things. I have shared my GitHub link. I have shared my mail ID. Okay. Also my Medium account link. So there I basically wrote few of the articles. And nowadays I don't get time, but I wrote few articles related to the reinforcement learning and other AI related resources, how the people can make career on those areas. So you can just check it out if you wish. And few of my recordings of my sessions and the video bites are available in my YouTube channel also. I'm sharing them as well. So you can, if you wish, you can also access them. So please look into the Q&A section. Okay, I'm posting one by one everything. So I have shared my GitHub account link there. I have shared my mail ID. Okay, all those things I have mentioned there. Okay, YouTube channel link, Medium article link, all those things I have shared. And this particular repository has, due to lack of time, the hands-on part, I mean, I explained everything, but hands-on part is not completed fully. So I have shared this repository link in the comment box section, so you can easily access. Okay, and let me show it to you as well with the screen sharing mode as well. Okay, so these are the things you can check. So can you see the screen sharing? So this particular segment is the GitHub link for the Explainable AI. This is my mail ID. Okay.
Yes, sir.
I'm just highlighting one by one. So please access from your you can access from your Q&A section as well. And I'm just showing you one by one just what I have posted. Okay, this is my GitHub part. Okay, this is my GitHub part. Fine. And then also this is my Medium article link. This is my YouTube channel link. Okay, so these are the resources you can access. You can gain knowledge from there. Okay, and another part. So this is our one of the recent publications from our research group. So adaptive explainable AI framework for securing the consumer electronic based IoT applications in fog cloud infrastructure. It has been published in IEEE Transaction of Consumer Electronics, which is one of the reputed Q1 rank journal. Okay, so you can go through it. Okay, and those who are working in explainable AI area, you can go through the article. You can also cite this particular article as well. Okay, so I am sharing the article link in your comment box section as well. So those who wish, they can read it, they can cite it in their research. Okay.
Sir, can you hear me, sir?
Okay. Yes, yes. Please.
Sir, for a medical image purposes, which explainable AI is more preferable, sir? Medical image processing.
Yes, the medical image processing, financially, everywhere, explainable AI is important. Okay. Because you see, like I mentioned, that whenever you are making the disease prediction, if you can generate some explanation along with it, it will be immensely useful. Okay. So we have one article on the basis of the mental health, okay, where we have used the GPT-based explanation generation. So it might interest you. Okay, so you can check this article.
Sir, which explainable AI is preferable? There is SAP, LIME, or GradCam for medical image processing. Which one will be preferable, sir?
You can use any one. It depends up to your purpose. Okay, it depends up to the data you are handling with. It's up to you. There are many tools and techniques. Okay, you have to check that in your data set, which one is more interpretable. Okay, in tabular data format, for example, if you use the LIME, it is more useful. Okay, for CNN, you can use the like the techniques we recently implemented. For example, the GradCam, you can use that as well. Okay, so I am also sharing one article link. It has been published in IEEE Journal of the Biomedical Journal of Health Informatics. So here we have used, for example, the GPT-based explanation generation, GPTFX concept. So that also you can utilize. And for those, I have shared the link. I think it is posted there. It is posted there. And also those who are for your assistant purpose, I am also, let me show it through the screen share. So this is another contribution of the explainable AI based applications. Okay, from us. So this particular article also you can go through. This is the applications of the, as you mentioned, about the healthcare domain. So I'm just showing you. So GPTFX, a novel GPT-3 based framework for mental health detection and explanation. So here you will get the explainability, how it is helping patient through the explainability. Okay. So all those links, this particular article link I also posted here. Okay. So all those links I have shared. Okay. Go through them. In your research, please cite them. So two recent IEEE transaction paper link I have shared where we contributed on explainable AI. Okay, so please go through them and cite them. And for any query questions, you can reach out to me through email ID. I have shared my email ID. Okay, so is there any more query, or I think we can wrap it up because it's already 3:20. I think we are already
Yes.
we are 20 minutes more.
Yes, other participant, any question or any query? Okay. Thank you, sir, for this informative session. In your busy schedule, you have accepted our invitation. And all participants will share the all part. I got some message from some participant. Please share the resource person mail ID or contact number. Tomorrow at the end, day 5, I will share the all details of the all resource persons along with their email ID and contact number. And sir already shared their
I
GitHub
already
ID.
shared my details.
Yes, sir.
So they can access. And
Yes,
I will already they can. I mean, those who have the GitHub account or even they open up the link which I shared, they can get all the access of the notebooks. But separately, I will email you the notebooks. Okay, the 3 notebooks which I taught today, I will email you separately. Yes, but easily it can be accessible from the link which I shared.
Okay, sir. That will be better. Okay, sir. Thank you once again
Thank you
from
so much.
behalf of the MIT Academy of Engineering College. Thanks for delivering the session.
Thank you so much. Thanks for the kind invitation, and I am thankful to all the participants for
Thank you very much,
patience
sir. Thank you.
putting it sequentially to make this event successful. Thank you very much.
Yes, sir.
Thank you,
Yes, sir.
thank you, sir, for very knowledgeable lecture. We got
Thanks for your
many
time.
things we understood. Thank you, sir.
Thanks
I
for your
request to
precious.
all participants, please turn on your camera. We'll take one screenshot.
Sure. Yes.
Yes, I request to all participants, please turn on your camera. Okay.
I don't check up. I don't. Yeah. Three times. Coming back, he was there. Rajneesh. Lucky day.
Yes. Thank you. Thank you, sir. Thank you, all participants. We'll conclude the session. Thank you.
Okay.
Thank you very much, sir.
Thank you.